So now looking at syllabus statement 1.15, deduce the number of outer electrons in a main group element from its position in the periodic table. So our main group elements are group number 1, coming down, groups always go down. Group number 2 going down. Group number 3, here going down. Group number 4, here. Group number 5, group number 6, group number 7, and group number 0, also called group number 8. Okay, so deduce the number of electrons in a main group element from its position in the periodic table. So again, we're going to pick a couple at random here, and we'll try and pick 2 in the same group so you can see the trend. Okay, so looking at chlorine, or we'll look at fluorine actually, and we'll look at bromine. So fluorine on here is 19.9. So let me just go down along. 19.9. And bromine is 80.35. Okay, and bromine is 80.35. So we want to deduce the electron arrangement. So again, we just fill our shells up like we did in the previous video clip. So the electron arrangement for fluorine, let's fill them up. We need 9 in total. So we need 9 in total. So that's going to be 2. And we got 7 leftovers, 2, 7. Now bromine has got 35 in total. It's quite a lot, isn't it? We need to keep adding up in our heads here. So we've got 2. Fill the second shell. 8's all you're allowed to fit in it. Fill the third shell. Now the third shell can fit 8 or 18. Okay, so the third shell is going to be full. So we're going to have 18. So how many have we got so far? We've got 2, 8, 18. So we've got 28 and 28, and we've got 7 left over. So that's 7 in the outside shell. So you can see, if you look up the top again, that both fluorine, chlorine, bromine and iodine, these are all in group 7. And the trend is that they all have 7 electrons on the outside shell. Okay, so that's what it means, deduce it based on its position in the periodic table. I'm just going to do 2 more for you. So lithium we're going to do, and sodium. Lithium 7.3 and sodium 23.11. Okay, so lithium has 3 electrons in total. So it's got an electron arrangement of 2, 1. Sodium's got 11 electrons in total, and it's got an electron arrangement of 2. Fill the second shell, 8. And the next shell is going to be 1. So 2, 8, 1. Okay. So there you have it. So they are both in group 1, and they both have 1 electron on the outside shell. Now I'm just going to do 1 more. We're going to do potassium for you. Last one is potassium, just to give you another idea of what's going on here. So potassium is going to be 39, 19. Okay, so that is 2 in the first shell. We have fill the next shell, 8. Next shell is the third shell, so we're going to put 8 in the third shell, and finally 1 on the outside shell. Is that correct? So 2 and 8 is 10, and 8 and 1, 19. Now that's correct. Now just another tip on that, right? Because in the bromine we put 18 in, but here's your tip. So potassium's got 19, and potassium has 3 shells. It's got 4 shells. So it's got 2 in the first shell. It's got potassium has 8 in the next shell. It's got 8 in the next shell. And it's got 1 in the last shell. So potassium is in period 4. So potassium has 4 shells. Bromine is in period 4, so bromine has 4 shells. But in order for bromine to have its 7 on the outside shell, it needs to fill 18 into the third electrons. Now, a basic way of remembering this is if it's beyond the transition metals here, like gallium, arsenic, selenium, and so on, it will have 18. So iodine would be an 18 one as well. So on this side of the period, the non-metal side of the periodic table, they will often have the 18 in the third shell. Now in general, they tend to ask you quite the same questions. They ask you the halogens, because that's one of the groups you study, so group 7, and they ask you group 1, the alkaline metals, because that's also a group you study. And when they want to be awkward, sometimes they ask you a couple out of group 2, which is the alkaline earth metals. Lastly, they might ask you the noble gases, which are group 0, and they always have full outer shells. So they will fill what you can fill into that one. So the helium would be 2 electrons on the outside shell. Neon would be 8. This one would be 8. This would, in krypton would be 18. Okay. So there you have it. Looking back at our syllabus statements, deduce the number of outer electrons in a main group element from its position in the periodic table. Okay, so when it's asking you for outer, remember you just draw the outer. Now for the examples, I did you a couple more just so you could see where it was coming from, but the outer shell electrons will be equal to the group number.